Number 2 is a little different than number 1 because what you'll notice is that we have logs on the left-hand side of the equation, but not the right-hand side of the equation. And even if we took, let's say, one of these log terms, let's say we subtracted this to move it to the right-hand side of the equation, well, then we would have 2 minus a log expression. So it would be, we wouldn't be able to get one single log term on the left-hand side and one single log term on the right-hand side to get them to cancel off. So we have to go about this using a different technique. All right, well, let's start this the same way we did number 1. Let's combine these two log expressions. And since there's an addition sign between these two expressions, we can combine them into one single log term by multiplying the x minus 6 and the x minus 6. All right, so from this point, if you want to double distribute this all out, we'll wind up with log to the base 8 of, all right, x times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6x. And negative 6 times negative 6 is positive 36. And I'll bring down the equals 2. And if we want to combine these like terms real quick, we can. So we have log to the base 8 of x squared minus 12x plus 36 equals 2. All right, well now, if you have log on one side of the equation and not the other, what we want to do to get rid of the word log is we circle the base and run the race. So that's going to leave us with x squared minus 12x plus 36. And we move this 8 over to the other side of the equation as the base on the 2. So this is going to be 8 squared. Now we know that 8 squared is equal to 64. So we'll just rewrite this with a 64 on the right-hand side of the equation. And to finish solving, since we have an x squared in our equation, we're going to need to move everything to one side of the equation. That way we can factor, make a t-chart, and solve. And remember, if something doesn't factor, you can always use the quadratic formula to solve. But this does factor. There are two numbers that multiply to negative 28 and add to negative 12. That would be negative 14 and positive 2. So our factors are x minus 14 and x plus 2. So now we make a t-chart. And we get x equals positive 14 and x equals negative 2. Now, something I should have mentioned when we did number 1 is you always want to go back and make sure that when you substitute your values of x into the original equation, it doesn't create a negative log anywhere. Because remember, we're not allowed to have a negative log or a 0 log. So if we take this 14, x equals 14, and substitute the 14 back in right here. 14 minus 6 is 8, positive 8. That's okay. You could have log of a positive number. And same thing here. It'll create a positive number. So this answer is okay. Now, if we take a look at the negative 2, if you take this negative 2 and substitute it back in here, negative 2 minus 6 is negative 8. You can't have log of a negative number. So this value we're going to have to cross off. I'm just going to write out just so we can visually see it. You cannot have negative logs. Okay. Let's just try out one more example. This one starts off the same as number 2. We have, logs on the left-hand side of the equation, but not on the right. So this time we can combine these two expressions using division. Since this is subtraction, if we want to make them into one single log term, what we can do is we can divide the x squared plus 3x by the x plus 5. Okay, now that we have one single log term on the left-hand side of the equation, we can circle the base and run the race. So what happens is we're left with x squared plus 3x over x plus 5 equals 4 to the first power. Now 4 to the first is just equal to 4. So if we want to rewrite this, x squared plus 3x over x plus 5, I'm going to take that 4 and put it over 1. And the reason I'm doing that is because if we have a fraction on the left-hand side of the equation, let's take this and make it into a fraction. That way we can just cross multiply and solve. All right, so I'm going to multiply the top left by the bottom right. So x squared plus 3x times 1 is just x squared plus 3x. And I'll bring down the equal sign. And now let's multiply the top right by the bottom left. So 4 times x is 4x. And then 4 times 5 is 20. positive 20. All right, again, because we have an x squared in our equation, we're going to get everything to one side of the equation. So let's subtract 4x and subtract 20. That's supposed to be a 20. Minus 4x minus 20. So on the right, everything cancels, and on the left, we have x squared. Positive 3x minus 4x is negative x, and then we'll bring down our minus 20. All right, so now, if we factor this, we wind up with x minus 5 and x plus 4 being equal to 0. So our two values this time are positive 5 and negative 4. Now, one thing I want to note is that I know this is a negative value here, x equals negative 4. We don't cross it off just because the value is negative. We cross it off if, when we plug it back into the original equation, it creates a negative. Because remember, you're not allowed to have log of a negative number. So let's start off with the negative 4. Let's plug it in. Well, negative 4 squared is positive 16, plus 3 times negative 4 is negative 12. So 16 plus negative 12, just 16 minus 12, is positive 4. That actually creates a positive log. So far we're good. Let's try it over here. All right, well, negative 4 plus 5 is positive 1. Again, it creates a positive log. So even though x equals negative 4 is a negative number, it creates positive logs. All right, and then when we check our 5, we get 5 squared, which is 25, plus 3 times 5, which is 15. So 25 and 15 is positive 40, so that's okay. And then over here, 5 plus 5 is positive 10, so that's okay as well. So both answers work in this case.